Representative versus biased samples. In this lecture, we will learn the difference between a representative sample and a biased sample. For the record, if you're interested in the truth of some matter, representative samples are superior to biased samples. Why? Well, a representative sample accurately captures information about a population's features. One of these features, if we were going to talk about killer whales, might be how much do they weigh on average? How old are they on average? How many fish do they eat in a day on average? When we talk about a population's features, this is another way to say population parameter. When you see population parameter, just think of a population's features. And think back to killer whales and how much on average they weigh as an example. Returning back to our first point, that representative samples are superior, biased samples are inferior. Biased samples do not accurately capture a population's features. That is, biased samples do not accurately estimate the population parameter. If that's kind of hard to remember, here's a handy mnemonic. Biased is bad, representative is rad. Rad is 1980s North American English for good. Let's have an example, so this can make a bit more sense to you. The difference between representative and biased makes more sense once we have an example. Let's imagine a satellite city, Trabant City, orbiting our planet Earth. So this is a city up in the sky orbiting Earth. It has 100,000 inhabitants from 3 different planets. Satellite City has 100,000 inhabitants, and of these inhabitants, 30% or 30,000 are from Terra, that's Earth. 30% or 30,000 are from Mars, and 40% or 40,000 are from Venus. So we have Terrans from Earth, Martians from Mars, and Venusians from Venus. This will be an example of a biased sample of Trabant City's population. Say you decide to follow your interest in geography by working in outer space, or at least beyond Earth's orbit. You decide to move to Trabant City and write a book about your experiences there. Well, you don't know exactly how many sentient beings in this case would be Terrans, Martians, and Venusians. You don't know how many sentient beings reside in Trabant City. However, you have managed to pick up all the major languages and their dialects spoken there. So after you've lived in orbit about a decade, and by this time, unless Trabant City spins really well, your bone density mass has probably decreased precipitously, so you'll never actually be able to return to Earth again, and you may have been bombarded with lots of sort of cosmic radiation, but that's a different story. After a decade, you are well acquainted with the ways of Trabant City. A friend of yours in the CBC asks you to begin reporting about daily life in orbit. Given the rarity of alien beings on Earth, so the atmosphere is dangerous to Venusians and the gravity is too strong for Martians, you decide to estimate the racial characteristics of the city's inhabitants so that your listeners will have a feel for how often you rub elbows with the antennae of the Venusians and the Martians. To collect this data, let's suppose that you wait outside only one airlock. And this is an airlock that's favored by Martians. So an airlock, for those of you who don't like science fiction or submarines, an airlock is a door that prevents air from escaping. There are 100 airlocks on Trabant City. You wait outside one that tends to be favored by Martians. So it's an airlock that leads right to the heart of New Mars suburbs. And you go there, you hang out at the airlock, and you count every 5th being leaving or entering Trabant City to estimate the population. You'll want to ask yourself this question before we go any farther. What problems do you think choosing the single airlock might cause for our sampling design? So how might this sampling design bias your estimate of the population? Okay, let's go to the next slide. We can imagine that if this airlock were heavily favored by Martians as a means to enter and exit Trabant City, we would count a disproportionate share of Martians entering and leaving through the airlock. Probably far more than 30% of the beings we counted would be Martians. So this sampling design would likely capture a sample with far more than 30% Martians. We also could imagine that if this were a door that were heavily favored by Martians, that this sample would not only overestimate the number of Martians, but it would underestimate the number of Terrans and Venusians. If we counted every fifth being leaving that particular airlock, we would not be surprised to find in our sample that only 15% were Terrans and 10% were Venusians. But a whopping 75% were actually Martian. When we compare these sample findings to the real racial composition of Trabant City, we see that this sample clearly overestimates Martians, but underestimates Terrans and Venusians. So we can go over here. We can compare the actual, sort of the true population characteristics with the sample characteristics, and we see that our sample shows that our sample has half as many Terrans as we would expect, has quarter as many Venusians as we expect, but it has 2.5 times as many Martians as we would expect. This is an example of a biased sample. It's biased because it deviates widely from the actual population. In other words, the sample population does not represent or reflect accurately the features of the population from which it was drawn. Now, let's have an example with a representative sample of Trabant City's population. So if instead we had a list of all inhabitants, which you hope you would on a space station or on a satellite city, and you numbered all of these inhabitants from 1 to 100,000, and then we got on the equivalent of the telephone, called every 100th individual, our sample would likely be more representative since we selected from all the individuals in the population. Or we were more likely to sample from all the individuals in the population. All other things being equal, this sample would probably produce a more representative sample than did the previous example. And so it really, in this instance and in the previous instance, it comes down to something called the sampling frame. A sampling frame in the first example with the airlock essentially acted as the sampling frame. In the second example, the sampling frame is the list of all inhabitants. The sampling frame defines the possible inhabitants that we would contact. So in the first sampling frame, because it is mainly used by Martians, it will have lots of Martians. Whereas in this list, in the second sampling frame, this list includes everybody that lives on Trabant City. Why is this representative? Well, it's representative because each individual in the population has the same chance of being selected, at least before we decide on our spacing between individual addresses. So we could have decided to pick every 50th or 75th individual, and instead of getting person number 1 as the first person that we start from, we could roll 100,000 sided die or generate a random number from 1 to 100,000, pick that individual, call them first, and then, so if that individual were number 932, the next individual we would call would be individual 1032. We're more likely to get a representative sample if each individual in the population actually has a chance of being selected. So we can imagine a representative sample like the one we see here. We know that on Trabant City, there's actually 30% of the population are Earthlings or Terrans. And in the sample, 33% over here, so 33% of the sample consisted of Terrans. Martians were 30% of the population, but in the sample, again, they were 29%. Pretty close. 29% is pretty close to 30%. 33% is pretty close to 30%. And then for the Venusians, the sample indicated that 38% of the sample consisted of Venusians, whereas in actuality on the space station, 40% of the population are from Venus. So this sample slightly overestimates Terrans and slightly underestimates Martians and Venusians. In representative samples, that's pretty common. It's very rare that a representative sample will precisely mirror the population parameter. Instead, you'll get something that's pretty close to the population parameter or the population features. This sample then is a much better estimate because it is much closer to the true population values. This sampling procedure assumes that every 100th individual is not systematically different from the rest of the population. It could be that we picked a sample in which every 100th individual just happened to always be a Martian, or a Venusian, or a Terran. And in that case, our sample would have returned either 100% Martian, 100% Venusian, or 100% Terran. But that's really unlikely to happen. So in both cases, in the biased example and in the representative example, in both cases, these are examples of systematic random sampling. So we used something called systematic random sampling. That's where you pick every xth individual, so it could be every 5th individual coming through an airlock or a door or leaving a grocery store, or it could be every 100th individual or 33rd individual or 97th individual on a list. So remember that the first example relied on this kind of systematic random sampling too, but it returned a biased sample because the sample frame, the pool of individuals that could be sampled, was mainly full of Martians, since Martians heavily favored that airlock. The first example would not be a biased sample if we were just interested in finding out who uses this airlock the most. So if we were interested in finding out who used that airlock the most, well, we know that it was 75% Martian. In that case, that wouldn't be biased. But if we're going to try to apply the results of that sample to the entire space station, then it does not accurately reflect the actual population characteristics, the actual population parameter regarding race for Trabant City's population. Both of these examples made use of something called systematic random sampling. Why do we care? Well, as you can imagine, it is very expensive and time-consuming, if not impossible, to conduct or to enumerate a census. Still, despite this, we want to estimate with as much accuracy as possible some characteristics of a population. When we want to do this, we need to remember that we want a representative sample. Why do we want a representative sample? Unlike a biased sample, representative samples are more likely to be the best estimate of the population characteristic we want to know about. We'd like to thank NASA for this lovely picture of a satellite, and it is an open source image.